Let us study some methods for the preparation of amines. The first one is alkylation of ammonia by alkyl halides. Now this is an alkyl halide. We are taking 2 moles of ammonia. It is going to give amine along with a salt. NH4 X negative is a salt. Now students, this salt can undergo a reversible reaction. A hydrogen from this NH3 can get attached to X atom, which can be Cl or Br, giving hydrogen chloride or hydrogen bromide along with an amine. Now students, when an alcoholic or aqueous solution of ammonia is heated with alkyl halide, a mixture of primary, secondary and tertiary and even quaternary ammonium salt is obtained. Now look at the chemical reaction. This is ethyl iodide. When it is going to react with ammonia, what is going to happen? The lone pair is going to attach to the carbon atom and this bond will be broken down and one of the hydrogens will get attached to iodine, giving hydrogen iodide along with ethyl amine. In the second step, what is going to happen? That another molecule of ethyl iodide is going to react with this ethyl amine. The lone pair of this nitrogen is going to attach this ethyl group along with it, giving you a secondary amine. And this secondary amine is further going to react with another molecule of ethyl iodide, giving you a tertiary amine. Now students, this tertiary amine can further get alkylated to give you a quaternary ammonium salt. Why? Because nitrogen is already making 3 bonds with 3 ethyl groups. When it is going to make the fourth bond is going to give a positive charge on the nitrogen atom. And that positive charge can attract the negatively charged iodide ion, giving you a quaternary ammonium salt. It is just like a salt, like Na positive and Cl negative. So it is a quaternary ammonium salt. Students, the next methods for the preparation of amines are reduction of nitrogen containing functional groups. The first one that we are going to study is the reduction of nitro compounds, means compounds containing NO2 group. Nitro compounds on catalytic or chemical reduction produce primary amines. Nitroarenes means NO2 group when it is attached to aromatic compounds can be reduced to primary aryl amines. Typical reducing agents include iron in the acidic medium, tin in the acidic medium, or catalytic hydrogenation, which you have studied so many times, hydrogen in the presence of platinum. Now students, this is a benzene ring attached to NO2, which is nitrobenzene. We can reduce it in the presence of tin, HCl, and it is going to give aniline, NH2C6H5. This NO2 is reduced to NH2 group. Similarly, in the other example, you can see that this NO2 in the presence of iron and acid is reduced to NH2 group, giving us diaminobenzene, para-diaminobenzene. The second nitrogen containing functional group are nitriles. So we are going to study the reduction of alkyl nitriles to produce amines. Reduction of alkyl or aryl nitriles gives primary amines. The reduction may be brought about lithium aluminium hydride or sodium in ethanol. So these are the reducing agents. Catalytic hydrogenation with rhodium in the presence of aluminium oxide, platinum or Rene nickel may also be used to get the primary amines. Now students, you can see this is methyl nitrile. We are going to reduce it in rhodium in the presence of aluminium oxide. Now you can see that reduction is taking place on this carbon atom and nitrogen atom. This carbon is converted into CH2. This nitrogen is converted into CH2, giving you ethyl amine. Similarly, this is an aryl nitrile. You can see we can do the reduction in the presence of nickel and hydrogen at 300 degrees Celsius. This carbon and nitrogen will get reduced and will be converted into CH2 and NH2, as you can see over here. Now students, this is also a nitrile group. It can also be reduced by using lithium aluminium hydride, which is also a reducing agent. This carbon is converted into CH2 and nitrogen is also converted into NH2. So students, this is how we can reduce alkyl nitriles into primary amines. The next nitrogen containing functional group is amides. We are going to reduce amides to get primary amines. An amide on treatment with bromine in the presence of potassium hydroxide yields primary amines. The reaction occurs through rearrangement. Now students, when we are going to reduce an amide, this is amide R C double bond O NH2, using lithium aluminium hydride, which is a reducing agent. So this carbonyl C double bond O will get reduced into CH2 group, as you can see over here. And in this way we are going to get an amine. Similarly, this is an amide. If we are using potassium hydroxide and bromine, it is also going to convert it into a primary amine. This carbon is going to get converted into carbon dioxide, giving CH3NH2. Now students, one carbon less amine is going to be produced when we are using bromine in the presence of potassium hydroxide. But when we are using lithium aluminium hydride, you will have the same number of carbon atoms in the primary amine. This is a very important point to remember. Look at this example. This is an amide. When we are going to use bromine in the presence of potassium hydroxide, one of the carbon will be converted into carbon dioxide and the rest you are going to get an amine. This is a primary amine. Students, let us study some chemical reactions of amines. Reactions of amines with alkyl halides, we have already studied them also in the methods of preparation. Now this is methylamine. When we are going to react with it with an alkyl halide, what is going to happen? The lone pair of the amine is going to attack on this carbon because it is partial positive and this chlorine is partial negative. Now what is going to happen? It is going to get attached to this carbon atom and making a fourth bond. That is why it is carrying a positive charge. This Cl negative will leave as a nucleophile. Now this nucleophile is going to abstract this proton from this cation and it is going to get converted into HCl, giving you a secondary amine. Now students, let us see how amines react with aldehydes and ketones. Aldehydes and ketones react with primary amines to form a Schiff base. Now let us see what is a Schiff base. This is an aldehyde. You can also get a ketone. This is a primary amine. Now students, it is going to react in such a way to give you an imine. This is a Schiff base along with water. Now what is going to happen? These two hydrogen atoms and this oxygen are going to combine to give you water, H2O. And this carbon is going to make a double bond with this nitrogen. A carbon, when it is making a double bond with nitrogen, it is called an imine. And this is a Schiff base. Now students, let us see the reactions of amines to give amides. When an amine is going to react with acyl chloride, this is an acyl chloride, it is going to give an amide. Now students, this is a secondary amine. When it is going to react with acyl chloride, the lone pair is going to attack on this electrophilic carbon and this pi bond will be broken down, giving a negative charge to the oxygen. That oxygen is going to attach to this hydrogen, giving you this complex. Now in the second step, what is going to happen? That this OH bond is going to break down. This bond is going to shift between carbon and oxygen, making a double bond, and this chlorine is going to get released and attached to this hydrogen, giving you HCl. Now students, you can see this is R group, C double bond O, and this is a derivative of amino group NH2. Instead we are having NCH3CH3 because in the start we had taken a secondary amine. So this is the reaction of amine with acyl chloride to give you an amide. Now students, anhydrides, they also react with amines in the presence of a base to give you amides. Now students, let us see how we use amines for the preparation of diazonium salts. Amine, when it is going to react with HNO2 nitrous acid, it is going to give diazonium ion, or N having a triple bond with another nitrogen atom. When both of these are going to react, it is going to give diazonium ion, a hydroxyl ion, and water. Now students, this diazonium ion, it is highly unstable. It can exist only at -5 or below temperature. Now what is going to happen as soon as this diazonium ion is produced? If we are unable to keep the temperature low, this NN making a triple bond can get released by making a nitrogen gas molecule. The bond between this carbon nitrogen is going to be broken down and reside on this nitrogen because it is carrying a positive charge. It wants its lone pair back. Now in this way it is going to be a stable molecule, N2, which is going to be a gas and can escape out from the chemical reaction. Now you are left behind with CH3CH2 with a positive charge because its valency is not satisfied. Now students, if there is moisture or water, what is going to happen? This CH2 group, the carbon, is going to attach with the hydroxyl OH group of water, giving you an alcohol along with H positive from the water. And if nothing is present, then this cation is going to stabilize itself, making a pi bond by the release of one hydrogen atom and making a double bond between these two carbon atoms. Now this diazonium ion is used for the preparation of many other functional groups. It is a very important laboratory reagent. Now students, when this diazonium group is attached to benzene ring, it is somewhat stabilized due to resonance, because this pi system and this lone pair can get involved in the resonance and it can stabilize to some extent as compared to its aliphatic analog. So when this diazonium ion is attached to a benzene ring, it is somewhat stable, but it decomposes readily at 10 degrees Celsius. Students, try to understand the concepts, practice the chemical reactions,